Why humans trigger confusion in wild predators. A wildlife researcher studying big cat behavior in Kenya documented something in 2013 that forced her to reconsider how predators categorize threats in their environment. She was tracking a lioness that had been hunting unsuccessfully for 3 days. The big cat was visibly desperate. Ribs showing. Movement slower than usual. Every hunting attempt had failed. The lion was approaching a state where poor decisions become survival decisions. A stickman human appeared on the savannah. By every measure of predatory logic, the human should have been evaluated as prey. Small. Alone. Moving slowly. No obvious weaponry. Wounded animals in predatory decline make the worst decisions, and desperation overrides caution. The lioness approached. The researcher watched through binoculars as the big cat moved toward the human with purposeful strides. This was not investigation. This was hunting approach. 30 meters away, the lioness stopped. She did not charge. She did not continue closing distance. She turned and walked away from the human and back toward her cubs without completing the approach. The researcher's notes asked a question that haunted her analysis for years afterward. What did the lioness see that made her abort an approach to potential prey in a state of desperation where that prey should have represented an acceptable risk? Start with what predators need to understand about prey for hunting to work. A predator's hunting system is built on pattern recognition. The shape of the prey. The movement pattern of the prey. The size category of the prey. The speed of the prey. The herd composition. The vulnerability signals. Every piece of information gets fed into a decision tree that has been refined across millions of years of evolution. The system works because prey animals produce consistent patterns. A gazelle moves like a gazelle. An antelope moves like an antelope. The movement pattern is legible. The predator's brain has a file for that movement. The predator knows what the next 3 seconds of movement will look like. A human walking across a savanna produces a movement pattern that does not match anything in a predator's file. The gait is wrong. Humans walk on 2 legs with an alternating pattern that no quadruped prey animal produces. The balance point is different. The speed profile is different. The turning radius is wrong. The acceleration capability is invisible from the predator's perspective because humans accelerate differently than prey animals accelerate. But movement pattern confusion alone does not account for predators abandoning hunts. There is something deeper happening in predator perception when a human appears in the environment. Researchers studying predator cognition have documented what they call the predatory decision cascade. A series of rapid evaluations that happen in milliseconds as a predator assesses whether prey in front of it is worth pursuing. The cascade includes size assessment, vulnerability assessment, caloric return assessment, injury risk assessment, competition assessment, energy cost assessment. The predator's nervous system runs through this entire decision tree in the time it takes a human to blink. When the cascading evaluations hit a human, the system produces confusion. Size assessment fails because humans are vertical and predators expect horizontal prey. Vulnerability assessment fails because humans move in ways that are unpredictable from the predator's standard prey movement files. Caloric return assessment fails because the predator has no experience with human tissue composition. Injury risk assessment fails because humans behave in ways that are outside the predator's experience with prey animals. The predatory decision cascade is built for speed, not accuracy. The system works excellently when the animal in front of the predator matches the patterns the predator has been calibrated to recognize. When the animal does not match those patterns, the system produces not careful re-evaluation but cascade failure. A predator approaching a human is not running a high-level cognitive evaluation of whether this is actually prey. The predator is running an automated system that has been optimized for speed. The system encounters input that it does not have a clear response pattern for. The system's response to unclassifiable input is not to attack. It is to pause and request more information. That pause is what the lioness showed when she stopped 30 meters away from the human on the savannah. The predatory cascade had encountered something it could not process. The output was not go or no-go. The output was insufficient data. There is a component of predator perception that research has only recently begun to map in detail. Predators read prey through the lens of predatory availability. Is this prey in a state where it can be caught? Is it alert or distracted? Is it running or walking? Is it grouped or solitary? Is it injured or healthy? Every piece of information is gathered in the context of whether the prey is available for predation right now in this moment. Humans violate every single one of those assessment parameters in ways that are deeply confusing to predatory cognition. A human is vertical when predators expect horizontal. A human maintains awareness in ways that are different from prey animal awareness. A human's response to a predator's presence is not the standard prey animal flight response. A human does not flee in predictable directions. When a predator assesses availability, it is asking, will this prey animal cooperate with my predatory sequence? The human moving across the savanna is not cooperating with the sequence. The human is doing something the predator has no template for. Some of the most detailed documentation of this confusion comes from research on leopards in areas where human presence is relatively recent. In regions where leopards have had minimal contact with humans historically, documented attacks are more common than in regions where leopard-human contact has been long established. Researchers initially interpreted this as habituation. Leopards in contact zones learning that humans are not prey. But more careful analysis revealed something different. Leopards in contact zones were not learning that humans are not prey. Leopards in contact zones were learning that humans are unpredictable in specific ways that make them poor hunting candidates. The leopards were not less afraid of humans. They were more accurately assessing humans as low-value predatory targets precisely because they had more experience with human unpredictability. The confusion that causes predators to abort human hunts is not something that gets resolved through experience. It is something that gets refined. Which brings everything back to that lioness stopping 30 meters from a human on the savanna. The lioness was desperate. By every measure of survival logic, the human should have represented an acceptable risk. But the predatory decision cascade had encountered something it could not process. The lioness did not know the human was dangerous. There was no warning display. No obvious weapon. No behavior that communicated threat in a way the lioness could read. What the lioness was reading was something stranger. The human was unclassifiable. The human was not behaving like prey. The human was not behaving like threat. The human was not behaving like anything the lioness had evolved to understand. That confusion created a decision outcome. Not attack. Not clear avoidance. Abort approach. Request more information through a pause. The deepest confusion predators experience with humans comes from a single variable that most predators struggle to read. Unpredictability at a level that is genuinely novel. Prey animals are unpredictable in specific ways. They flee in certain directions. They climb certain types of obstacles. They respond to predatory presence in ways that other prey of their species also respond. Humans are unpredictable in ways that have no parallel in predatory experience. Humans pick things up and use them as extensions of their reach. Humans make sounds that are designed to startle rather than produced by fear. Humans run in directions that have no logical relationship to their body position. Humans fight back against predators in ways that are genuinely dangerous in unpredictable ways. A predator can model gazelle behavior in advance. The predator has no accurate model for human behavior because humans behave in ways that are outside the predator's evolutionary template. There is a principle underneath all of this that predators appear to understand at a level far below conscious articulation. Novel unpredictability is threat. An animal that behaves in ways you have not evolved to predict and cannot easily categorize is an animal that represents unknown injury risk. The predatory decision cascade flags that unknown as a reason to pause before committing to an attack that might go wrong in unexpected ways. The lioness on the savanna was not thinking this through in human terms. She was not reasoning that the human might have weapons or group support or any other concrete threat. She was responding to something simpler and more fundamental. This prey does not fit the pattern. This prey will not cooperate with my predatory sequence. This prey might do something my evolved experience cannot predict. That uncertainty was enough.